All right, so let's look at one of the apex exercises. We want to find the extreme values. So both the relative or local absolute min and maxes and the absolute mins and max. So one thing I'll point out here is that we have a function that is, so this is a polynomial, which means it's continuous everywhere. And we're looking on a closed interval, which means the absolute min and the absolute max to exist, and they have to be achieved on this closed interval. So we know what we're looking for exists. So where do absolute mins and maxes happen? They happen at basically two kinds of places. Endpoints of interval, and they also happen at critical points. Or I shouldn't say they happen at these points, but they might. So there are places we have to look. So let's do this. Let's evaluate this function at its endpoints. F of 0 is equal to 0 plus 3/2 times 0. So this is going to be f of 0 equals -6, and f of 3 equals 3 cubed plus 3/2 of 9 minus 18 times 3 minus 6. So 27 plus 27 halves minus 54 minus 6. What does this come out to be? This comes out to be -19.5. So those are the endpoints. Now let's find the critical points. So the way we find critical values is by taking the derivative. So 3x squared plus 3x minus 18, setting that equal to 0. So first thing I notice is that I can factor a 3 out of all these. So 3 times x squared plus x minus 6 equals 0. This quadratic factors to x minus 2, x plus 3 equals 0. And I get what two values? I get x equals 2 and -3, except I don't care what happens at x equals -3 because that's out of our interval. So I have three candidates. My two endpoints, which are x equals 0, x equals 3, and my one critical point, which is x equals 2. So what is f of 2? F of 2 equals 2 cubed plus 3/2 of 2 squared minus 18 times 2 minus 6. So that's 8 plus 4 times 3/2 is 6 minus 36 minus 6. 14 minus 42 is that -28. So I have three values here. Let's just write down what these points are. 0, -6. 2, -28. And 3, -19.5. So of these 3 points, I have to have an absolute min and absolute max. So we can find those right away by comparing the y values. So I believe this point right here is my absolute min. And I believe my absolute max is here. So I found my global extreme points, but now let's talk about where are relative extreme points. So we know we have a critical point. So we know that 2 is a critical number because f prime of 2 equals 0. I think based on these 3 points we have, we can say it's a relative minimum, but let's be sure. We can either do a sign chart of the second derivative, or I can take a sign chart of the first derivative, or I can take the second derivative and evaluate it at this critical number. So let's take a second derivative. What is f double prime of x? That is equal to 6x plus 3. So what is f double prime of 2? That is equal to 6 times 2 plus 3, or 15, which is a positive number, which means we have a relative min at that same point. That was the only critical value we had. So one thing I didn't bring up is that endpoints of interval, these and critical points, these are where absolute extrema might happen. But what about relative extrema? Where do those happen? Those only happen at critical points. So we only found one critical point, and we've already designated it as a relative minimum. So we have no relative maximum points on this interval.